This video about review for calculus, calculator-based continued. Look at the 6a. Let f of x equals this. For x between -3, 3. There is a local minimum point at A. Find the coordinate of A. Since this question is calculator-based, we will use a graphing calculator. So we put the y1 equals this. Figure out the minimum point at A. When you set up the window, remember the given domain that's from -3 to 3. Then the y, I just use from -4 to 4. Then you will get this graph. Then using the graphing calculator, you can get, when you have 1.999 stuff, that will be 2. So 2, -3.6. This will be the coordinate for A, 2, -3.6. Now let's go to 6b. On the following grid, sketch the graph of f clearly indicating point A. While you sketch the graph, this is the rule. 1 point for correct shape with the correct curvature. 1 point for intercepts. 1 point for maximum or minimum or sometimes inflection point if required. 1 point for endpoints. So for this graph, we know the intercept will be 0, 0. The minimum, that is 2, -3.6. And a maximum, that will be -2, 3.6. For the ending points, we have -3, 2.025. And for x equals to 3, then y equals -2.025. Then you can connect these points to sketch the graph smoothly. For second one, from 6b, sketch the tangent to the graph of f at A. We know it will be horizontal line. Let's go to 7a. Let f of x equals this, g of x equals this. The graph of f and g intersect at x equals p and x equals q, where p less than q. Find the value of p and q. For this g of x, we can do -3x e -x plus 1. Then we put into graphing calculator. This will be the y1, this is y2, so we can get the intersection. We put the y1 equals f of x, y2 equals g of x. For the window, I use Zoom 6, the standard window first. The intersection is not clearly. But I do know that the intersection will be between -5 to 5. That's the reason I changed the window like this. For the y-axis, I still doing the -5, 5. Then I got this graph. I could see this 2 is an intersection. So I use graphing calculator, get the x is 0.357. Then get the other intersection, that is 2.15. Since p less than q, so p equals 0.357. Q equals 2.15. For 7b, hence find the area of region enclosed by the graph of f and g. See the area equals. We already put the y1 equals f of x and y2 equals g of x. Then use the trace to find out which function is above. That's y1 is above. So we use integral. We put the y1 minus y2. Then do the definite integral. We get 0.538. So we can write down like this. Now let's go to 8a. All lengths in this question are in meters. Let f of x equals this function, x between negative 0.5 to 0.5. Use this f of x as a model to create a barrel. The region enclosed by the graph of f. The x-axis and the line x equals negative 0.5 and the line x equals 0.5. It's rotated 360 degrees about x-axis. This is shown in the following diagram. Use the model to find the volume of the barrel. In the formula, we can get this for revolution. Volume about x-axis. So volume equals pi times negative 0.5 to 0.5. Remember the f of x squared. So we put into calculator first. We make y1 equals f of x. Make sure your y1 equals negative 0.8x squared plus 0.5. Then we put into calculator like this. You will get the volume equals 0.601. Now let's go to 8b. The empty barrel is being filled with the water. The volume V of the water in the barrel after 10 minutes is given by this formula. How long will it take for the barrel to be half full? Half full means the volume will be 0.601 divided by 2. So we can set up the equation 0.8 y minus e negative 0.1 t equals 0.601 over 2. No matter what method you got to use to solve this equation by graphing calculator, make sure equals to 0. Therefore, you will get 0.8 y minus e to the negative 0.1 t, then minus 0.601 over 2. Then we can put this is a y1, then get the 0. I put the y1 equals this, and window, I set up the y between negative 3 to 3. If you set up standard window, you cannot see this x-intercept. So you get a graph like this, get a 0 that equals 4.71. So t equals 4.71 seconds. Let's go to 9a. A particle P starts from a point A and moves along horizontal straight line. Its velocity v after t seconds is given by this piecewise function. The following diagram shows the graph of v. Find the initial velocity of p. So we put t equals 0 to this piecewise function. That is negative 2, 0 plus 2 equals 2. 9b, p is at rest when t equals 1 and t equals p. Find the value of p. At rest means this velocity equals to 0. So we will put the y1 that equals 3 square root of t plus 4t squared minus 7 into graphing calculator. Then we try to figure out this x-intercept. We put the y1, this function, then get the x-intercept. That will be 5.22. So we get the t equals 5.22, which means p equals 5.22. Let's go to 9c. When t equals q, the acceleration of p is 0. So we can write down a of t equals 0. We do know the a of t, this acceleration equals derivative of velocity. We will set up equal to 0, which means we're looking for the minimum point of velocity function. So from graphing calculator, you can get this minimum point. This x equals 1.95, which means this q equals 1.95. Second question from 9c. Hence, find the speed of p when t equals q. Speed will be the absolute value of this velocity. So we can write down the speed equals absolute value of 1.76 equals 1.76. Let's go to 9d. Find the total distance traveled by p between t equals 1 and t equals p. From 1 to this p. So for first one, that's a distance equals, we do the definite integral from 1 to 5.22. Absolute value of a velocity function. Then put into calculator, you will get, make sure you put the y1 equals the velocity function. Then using this integral, you will get 4.45. Second question. Hence or otherwise, find the displacement of p from A when t equals p. Displacement, that means from 0 to p, 5.22. This p, that is 5.22. So from 0 to 1, this is negative 2t plus 2. For this 1 to this p, that is 3 square root of t plus 4t squared minus 7. So we will put, this is y1, we already put in, here's y2. So that the displacement equals from 0 to 1, that is a y2, then plus from 1 to 5.22, we do the y1 dx. Then you will get answer. Put into calculator, you will get the negative 3.45. Displacement is negative, which means on the left side of the origin. Now let's go to 10a. Let f of x equals this function for x greater than 3. The following diagram shows part of the graph of f. Find the equation of a vertical asymptote to the graph of f. The vertical asymptote line, you will make argument x minus 3 equals to 0. Therefore, x equals to 3. It's very close to 3, but never touch this 3. For 10b, find the x-intercept of the graph of f. We will set up y1 equals this. And then find the x-intercept. We put the y1 equals f of x. We can get the x-intercept that's equals to 4. So x equals to 4. For 10c, the region enclosed by the graph of f, the x-axis and the x equals 10. It's rotating 360 degree above the x-axis. Find the volume of a solid formed. According to this formula, we can write down volume equals pi times the x-intercept, that's 4. So from 4 to 10. Definite integral of f of x squared. Then we put into calculator, you will get, make sure y1 equals the f of x function. Then put into calculator like this. You will get the 142. Let's go to 11a. The velocity v of a particle after t seconds is given by this. The following diagram shows the graph of v. Find the value of t when the particle is at rest. At rest means velocity equals to 0. So we put the y1 equals this. Then find the zeros of the function. You put the y1 equals this velocity function. Then you draw the graph in the standard window. You could see the x equals 4.28. So t equals 4.28. Then this particle is at rest. Now let's go to 11b. Find the value of t when the acceleration of the particle is 0. Acceleration equals the derivative of velocity. We want to get this equals to 0, means we need a minimum value here. So we still go to graphing calculator, get the minimum point. From the graphing calculator, you can get the t equals 1.19. Let's go to 12a. F of x equals negative x fourth power plus 2x third power minus 1 for x greater than equal to 0, less than equals to 2. Solve f of x equals to 0. Remember, this question is calculator based. So we put y1 equals f of x. Then you will set up the window. Since the domain is given, so I use the given domain. Then the y minimum and the y maximum, I put the negative 5 to 5. You will get zeros, x1 equals to 1 and x2 equals 1.84. For 12b, the region enclosed by the graph of f and x-axis is rotated 360 degrees above x-axis. Find the volume of the solid formed. We know this is 1. This point is 1.84. We got to use this formula. Volume equals pi times definite integral from 1 to 1.84. Then f of x squared dx. You use graphing calculator, you put into a calculator like this, you will get 0.637. For number 13, a particle starts from point A and moves along a straight line. Its velocity after t seconds is given by this function. For t between 0 to 4, the particle is at rest when t equals pi over 2. That means this point is pi over 2. The following diagram shows the graph of v. Find the distance traveled by the particle for t greater than equal to 0 and less than equals to pi over 2. We got to use this formula. So we set up y1 equals v of t. Then we put into calculator like this. You will get 0.614. So the distance equals 0.614. For number 14, let f of x equals x minus 1 times x minus 4. Find the x-intercept. We will set up x minus 1, x minus 4 equals to 0. So x equals to 1 and x2 equals to 4. The region enclosed by the graph of f and x-axis. We see this is a 1. This is a 4. Just sketch the graph, and we do know that the graph open up like this. So the region enclosed by the graph and x-axis will be this part. It's rotated 360 degrees above the x-axis. Find the volume of the solid formed. We got to use this formula. So v equals pi times from 1 to 4, this definite integral of f of x squared. Then we will put the y1 equals this. Then we put into calculator. Your answer will be 25.4.